Alright, so I've gone back to my Samsung S5. The camera on it is awesome. I gave up on my Nexus 7s because, frankly, there's no SD card, and transferring files crashes them. And the Samsung S5 has an SD card, about 64 meg capability, and it's easy to take the card out, upload, put the card in my laptop, and upload a video. So, in a nutshell, I gotta go back to what works. So anyway, here we are with Electricity and Magnetism by Sylvanus P. Thompson. You know, right now I don't know what all this means here. These are some highfalutin titles. But what I do want to go over is some of these illustrations. Okay. So, right here we have a light, and we have two wires coming off the light, and they're possibly connected here and going up to this electric motor. And then you see it's connected here. You got some little, look like little Edison lights, or Christmas tree lights, or what do you want to call them. And then somehow this is connected as well. Don't know what it is exactly. So what you should ascertain is I don't know much about what this book has in store for us. So here's the spine. You see some kind of a bulb. And then that looks like a telephone, doesn't it? One of those old crank telephones. You crank it over here. The receiver and transmitter's right here. More cordage. And then nothing on the back. So I went ahead and bought two of these books. I was really impressed. So this one, I figured I'd have one, and one as a backup because really impressed with the content. So this is a backup, and it's a little bit worse shape. The seller thought that due to this signature there, that it might be a signed edition, but usually you would sign things in ink, and that's it's E something Thompson, but that's not Sylvanus P. Thompson. So maybe it's a relative, you know, or cousin. So you can get this online as a PDF. Elementary lessons in electricity and magnetism. Map of the United States and Canada. Shewing. Isn't that cool? That's Old English. Showing lines of equal magnetic declination for the year 1875. What does that say down there? Give me focus. Isn't it funny how people tell their cameras to focus as though the camera had ears? So I'm just read that for you. It says Sanford's George Establishment, I think. We can try to focus on that. What's the key here? Probably better lighting. I don't have good lighting here. I have an LED light bar. Okay, so that failed. Wait a minute. There it goes. Ah! It was there for a second. If I get more light, yeah, I think that's the trick. Alright, so freaked out for a second there. So what? I'm not having good times with this. So basically, just pause it on here somewhere. Oh, here we are. So it's talking about the magnetic declination. You can see it kind of fans out from the north and goes south here. I've never heard of that. Agonic line. So this is just some interesting things to understand here. Next page. A map of England showing the lines of equal magnetic declination and those of equal dip and intensity for the year 1888. So this is basically if you have a compass, magnetic compass, you've got to calculate for the variation between true north and magnetic north. And they were it's the same same folks I was mentioning before. This what Sunwards George and establishment or something like that. Right. So if I didn't lose you yet, they were trying to compare the declinations between the United States and England there. So, elementary lessons in electricity and magnetism. See if I can get this to focus better. By Sylvanus P. Thompson. A bunch of alphabet soup behind his name. Principal of and Professor of Physics in the City and Guilds of London Technical College, Finsbury. Late Professor of Experimental Physics in University College, Bristol. Revised and enlarged to date, including all the recent discoveries in X-rays, wireless telegraphy, etc., by Professor Otto H. Schwetzky, Leipzig, Germany. Thompson and Thomas, Chicago. Copyright 1906 by Thompson and Thomas, so over 100 years old. It's 2020 right now, so way over 100 years old here. Preface. These lessons in electricity and magnetism are intended to afford to beginners a clear and accurate knowledge of the experiments upon which the sciences of electricity and magnetism are based, and of the exact laws which have been thereby discovered. The difficulties which beginners find in studying many modern textbooks arise partly from the very wide range of the subject and partly from want of familiarity with the simple fundamental experiments. We have at the outset three distinct sets of phenomena to observe, viz. Don't ask me what that stands for. I'll have to look that up. Those of frictional electricity, of current electricity, and of magnetism, and yet it is impossible to study any one of these rightly without knowing something of them all. Accordingly, the first 3 chapters of this work are devoted to a simple exposition of the prominent experimental facts of these 3 branches of the subject, reserving until the later chapters the points of connection between them and such parts of electrical theory as are admissible in a strictly elementary work. No knowledge of algebra beyond simple equations or of geometry beyond the first book of Euclid is assumed. A series of exercises and problems have been added at the end of the book in order that students who so desire may test their power of applying thought to what they read and of ascertaining by answering the questions or working the problems how far they have digested what they have read and made it their own. Wherever it has been necessary to state electrical quantities numerically, the practical system of electrical units employing the volt, the ohm, and the ampere as units of electromotive force, resistance, and current respectively. Volt for electromotive force, ohm for resistance, and ampere for current, has been resorted to in preference to any other system. The author has adopted this course purposely because he has found by experience that these units gradually acquire in the minds of students of electricity a concreteness and reality not possessed by any mere abstract units, and because it is hoped that the lessons will thereby rendered more useful to young telegraphists to whom these units are already familiar and who may desire to learn something of the science of electricity beyond the narrow limits of their own practical work. Students should remember that this little work is but the introduction to a very widely extended science, and those who desire not to stop short at the first step should consult the larger treatises of Faraday, Maxwell, Thompson, Wiedemann, and Mascart, as well as the more special works which deal with the various technical applications of the science of electricity to the arts and manufactures. Though the author does not think it well in an elementary textbook to emphasize particular theories on the nature of electricity upon which the highest authorities have not yet agreed, he believes that it will add to a clear understanding of the matter if he states his own views on the subject. The theory of electricity is adopted throughout these lessons is that electricity, whether whatever its true nature, is one, not two. That is, that this electricity, whatever it may prove to be, is not matter and is not energy, that it resembles both matter and energy in one respect, however, in that it can neither be created nor destroyed. The doctrine of the conservation of matter, established a century ago by Lavoisier, teaches us that we can neither destroy nor create matter, though we can alter its distribution and its forms and combinations in innumerable ways. The doctrine of the conservation of energy, which has been built upon during the past half-century by Helmholtz, Thompson, Joule, and Mayer, teaches us that we can neither create nor destroy energy, though we may change it from one form to another, causing it to appear as the energy of moving bodies, or as the energy of heat, or as the static energy of a body which has been lifted against gravity, or some other attracting force, into a position whence it can run down, and where it has the potentiality of doing work. So also the doctrine of the conservation of electricity, now growing into shape. See note 1. So this is undoubtedly the outcome of the ideas of Maxwell and of Faraday as to the nature of electricity. Since the above was written an elegant analytical statement of the doctrine of the conservation of electricity has been published by Monsieur G. Lippmann, who had independently and at an earlier date arrived at the same view. Okay. But here, first enunciated under this name, teaches us that we can neither create nor destroy electricity, though we may alter its distribution, may cause more to appear at one place and less at another, may change it from the condition of rest to that of motion, or may cause it to spin around in whirlpools or vortices, which themselves can attract or repel other vortices. According to this view, all our electrical machines and batteries are merely instruments for altering the distribution of electricity by moving some of it from one place to another, or for causing electricity which accumulated or heaped together in one place to do work in returning to its former level distribution. Throughout these lessons, the attempt has been made to state the facts of the science in language consonant with this view, but at the same time rather to lead the student to this as a result of his study than to insist upon it dogmatically at the outset. City and Guilds Technical College, Finsbury, November 1905. Preface to 100,000. The ideas of Faraday, as enlarged and developed by Clerk Maxwell, which were just beginning to be understood in 1888 by a few advanced minds, have conquered the whole world of science, although even today their full logical consequences are appreciated by few. It is still to many incomprehensible that the conducting wire does not carry the electric energy, but serves only as a guide. That's hard on me too. Hopefully we'll learn to understand what this is as we go through this book. Besides the changes and additions necessitated by these great strides made by physicists and inventors, the startling discoveries of Marconi, Röntgen, and others have also been carefully embodied in the present edition of this volume. Otto H. L. Schwedzky. So we'll go over the contents, and then I'll conclude this video. And I think if I'm able to, each night we'll go over the lessons. There's a lot of lessons here. See lesson 367. There's lesson 287. So I'll go over some of the contents, and this is introduction and contents, and then we'll go over the lessons, I think, and then you can learn as we go. All right. So contents, page first, chapter 1, frictional electricity. So friction, like static. Lesson 1, electrical attraction and repulsion. Lesson 2, electroscopes. Lesson 3, electrification by induction. Lesson 4, conduction and distribution of electricity. Lesson 5, electrical machines. Lesson 6, the Linden jar. Is it Linden jar and other accumulators. Lesson 7, other sources of electricity. Chapter 2, magnetism. Lesson 8, magnetic attraction and repulsion. Lesson 9, methods of making magnets. Lesson 10, distribution of magnetism. Lesson 11, laws of magnetic force. Notes on ways of reckoning angles and solid angles. Table of natural sines and tangents. Lesson 12, terrestrial magnetism. That might have to do with those plates we saw. Should I keep going? How many of these? No, we got a little bit. Chapter 3, current electricity. Lesson 13, simple voltaic cells. Lesson 14, chemical actions in the cell. Lesson 15, voltaic batteries. Lesson 16, magnetic actions of the current. Lesson 17, galvanometers. Lesson 18, chemical actions of the current, voltmeters. Lesson 19, physical and physiological effects of the current. Part 2, Chapter 4, electrostatics. Lesson 20, theory of potential. Note on fundamental and derived units. Lesson 21, electrometers. Lesson 22, specific inductive capacity, etc. Lesson 23, phenomena of discharge. Lesson 24, atmospheric electricity. Chapter 5, electromagnetics. Lesson 25, theory of magnetic potential. Note on magnetic and electromagnetic units. Magnetic units. Note on measurement of Earth's magnetic force in absolute units. Note on index notation. Lesson 26, electromagnets. Lesson 27, electrodynamics. Lesson 28, diamagnetism. Chapter 6, measurement of currents, etc. Lesson 29, Ohm's Law and its Consequences. Lesson 30, Electrical Measurements. Chapter 7, Heat, Light, and Work from Electric Currents. Lesson 31, Heating Effect of Currents. Lesson 32, The Electric Light. Lesson 33, Electromotors, Electromagnetic Engines. Chapter 8, Thermoelectricity. 34, Thermoelectric Units. Thermoelectric Currents. Chapter 9, Electro-Optics. 35, General relations between light and electricity. Chapter 10, Induction Currents, Magnetoelectricity. 36, Currents produced by induction. 37, Magnetoelectric and Dynamoelectric generators. Chapter 11, Electrochemistry. 38, Electrolysis and Electrometallurgy. Chapter 12, Telegraphs and Telephones. Lesson 39, Electric Telegraphs. Lesson 40, Electric Bells, Clocks, and Telephones. Chapter 8, Wireless Telegraphy. Lesson 41, Ether Waves. Lesson 42, Wireless Telegraph Apparatus. Chapter 14, X-rays. Lesson 43. I'm having trouble with the Roman numerals, honestly. Vacuum and cathode rays. Lesson 44, X-rays. Chapter 15. Lesson 45, the central station. Lesson 46, modern dynamos and motor. Appendix. Problems and exercises. Index to chapters 1 through 12. And an index to chapters 13 through 15. Sorry. That's just so funny to me because I don't use those going up to so high. People like that study the Super Bowl and stuff, they probably know more how to rattle those off. So the thing that ether waves, 421, we might get a little sneak preview of that. There's a guy, Ken Wheeler, Ken, then Wheeler, like the Wheelers in Return to Oz. I already forgot the page number. Let's find that again. He talks about ether, like, constantly. 421. And it's really not, it's not really in vogue. So it's interesting. But apparently Nikola Tesla believed in ether waves. So Just get a little preview here. But yeah, Ken Wheeler's big deal. I bought his book. I have it on my tablet. And I was shocked. It seemed like it was like 6,000 pages. I'm not kidding you. But so yeah, it goes on to something else. But anyway, what I'm gonna do is go over a lesson a day, if I can remember to. And just stick with me, and we'll get through this. We'll learn this classic stuff. If you Google this guy's name on Wikipedia, he's very impressive. You might be able to decode his stuff. Right now, it's not ringing a bell. I think D is doctorate, maybe SC science. I don't know. I hesitate to screw it up. So anyway, there we go. Let's get on with our learning, right? Let's get the fundamentals done. And it gives me something to put on my channel, because my channel's hurting right now. Thank you so much.